rhombi and squares are all types of parallelograms, which means that all properties of parallelograms apply to those three shapes. So when we talk about rectangles, we're not going to talk about rotational symmetry or the angles bisect each other or opposite angles are equal or opposite sides are equal or opposite sides are parallel. Those are all parallelogram properties, okay? So every single thing that's true about a parallelogram is true about a rectangle, plus more, okay? The definition of a rectangle is a quadrilateral with 4 right angles. Most people know that. You know, that's not hopefully news to people that the 4 angles are congruent. Here it says to list everything, bless you, that's true about the rectangle. So we are not going to recite the parallelogram properties, okay? So let's just say out loud some of the things, but not necessarily write them. If you want to write them, you can. We'll mark them down. So opposite sides are equal. That's a parallelogram property. Opposite sides are parallel. That's obviously a parallelogram property. Opposite angles are equal, but they're all right angles. So all the angles are equal. We know that all the angles add up to 360, which makes sense. If there's 4 90s, that's a 360. Now, there's something special about the diagonals here. The diagonals bisect each other like they do in a parallelogram. And you guys tell me which of these you think is true. Do you think that the diagonals make a right angle with each other? What do you think? Are they perpendicular? Yes or no? They don't look like right angles, and there's no reason to believe those are right angles. What about this one? Do you think that they're the same length? Those two yellows. You do think that? Okay. So that is special about rectangles. Those would be the same length. And I could do a quick mathematical proof of this. This triangle right here has an angle that's a right angle, and it has these two sides marked the same as in this triangle. So those two triangles are equal, and if those two triangles are congruent, and in fact all 4 of these triangles, this one, and those 2 that I had before, those are all congruent triangles, and so this is the same in both triangles. So what I want you to do on these is mark this like this. They're bisected, and all 4 of these are equal. So the diagonals have an equal length. So they're not only bisected, but the diagonals have the same length. They're not necessarily perpendicular. Okay? Then I said a rectangle has 2 lines of symmetry. Draw them on the rectangle below. I'll draw a line. You tell me if it's a good line of symmetry. What do you think about this line? You think no? If I folded over that line, you imagine, folding over that like it's a sheet of paper, would it land on itself? Yeah. Okay, what about like this? No, that's the one that's no good. What about like this? Those are the 2 lines of symmetry. Okay? If you imagine the 2 lines of symmetry, then you could say, well, of course, if I fold this piece over, it would be equal to this one if I fold it over this line. Or if I fold it over this line, it would be equal to this one. So you can imagine those. The other things that are equal here are going to be angles like this angle right here is going to be equal to this angle over there. You don't have to draw those on yours, but you can just imagine if I flipped it, those would be equal. So there's a lot of equal angles in this diagram. You know what? Let's mark them. Let's mark the angles. Why not? So this angle is equal to this one, and this one, and this one. Does anybody notice anything about these triangles that you could say that we haven't said yet? In a parallelogram, this isn't true, but that yellow triangle, there's something special about it. It's isosceles. Yeah, it's isosceles. So notice it has 2 equal sides and 2 equal angles. So all these triangles are isosceles. These little ones in the middle, not all of them. So this triangle's isosceles too. They're all isosceles. And then go over here and mark these angles all equal like this. There's 4 equal angles like this. So in a parallelogram, I would have these angles equal, but in a rectangle, there's more equal angles. In other words, in a parallelogram, these 2 are equal, and use a different color, and these 2 are equal, but in a rectangle, all 4 of those are equal. So it's parallelogram properties plus more. Okay, the lines of symmetry, if you can understand it, you flip it over, anything that lands on itself, those are congruent pieces. Okay, key facts about a rectangle. It's a type of parallelogram. It has 4 right angles. The diagonals are, what goes on that? Congruent. They might say, I thought the diagonals bisected each other. That's a parallelogram property. It's automatically true about this shape. So again, I'm not listing all the parallelogram properties. The diagonals do bisect each other, but they're congruent. That's the difference between a parallelogram and a rectangle. They both bisect each other. These are congruent. It has 2 lines of symmetry. The word symmetry has 2 M's. A little messy there. Okay. So we're going to do some problems with rectangles. There's not a lot of problems here for rectangles. And then we're moving on to the next shape. So this will go kind of quick here. And there's something about this that we really have never done before, which we'll do today, and we'll see if it makes sense. Okay, RC is this diagonal. So RC is that diagonal. RT is this side, and ET is this diagonal. And it asks us to find some different things here. So I know that both those diagonals are split in half, but in a rectangle, I also know that they're equal in length. So for my equation, I'm going to say that yellow line and that blue line are equal. So the yellow one has to equal the blue one. The green one is not equal to either one of those. The green one would equal EC, but we don't know EC, so that's not really helpful. Okay, so we're going to subtract x from both sides. We're going to get the x on both sides. Let me switch colors here. We're going to move the x on one side. And this is pretty straightforward solving. I'm just trying to get x alone here. I'm going to add 4 to both sides. I'm going to end up with 7 here. Get x equals 7. No matter what you get, you would plug it in to check it. These should come out equal. I get RC equals 17. And I get ET equals 17. Now that I know x, I can plug that in and get RT. RT is 2 times 7 minus 6. That's 8. So this is 8. I could write an 8 right there. I didn't even have to look at these to know that I'm going to have to find x. I have to find x to do this. It has to be angle RTC. Now, for angle RTC, I didn't really need to do the solving. What's the measure of angle RTC, this big angle right here? Yell it out. You guys don't know. I mean, in a rectangle, those big angles are all the same, right? They're all right angles. So RTC is 90 degrees. Okay. Now they don't ask RT, they ask EC. But if you know RT, you can find EC because opposite sides are equal. So that one's 8. Those diagonals are 17. But it asks TC. How am I supposed to find TC? I know that TC is equal to RE. I know these two are equal, but I don't have either one of them. Tyler, what do you think? Oh, changing mind. Okay. How am I supposed to find that? I mean, I know that this length is 17. I know this length is 17. I know these opposite ones are 8. I know that RE and TC are equal, but I don't have either one of those. Yeah. Yeah. On rectangles, you could do Pythagorean theorem. On parallelograms, you know, unless you knew you had a right angle for some reason, you can't do Pythagorean theorem, but I could do Pythagorean theorem on this. So, let me just say a couple things. Some people might have been thinking like, this is 8.5, and this is 8.5, and this is 8.5. This is true, but it's not really helpful to know those are 8.5. Knowing that this is an this is an isosceles triangle, not really helpful either. It's true that it is, but it's not really helpful. So what I'm going to do here is I'm going to separate out a triangle now. That's a right triangle. So I'm going to use my highlighter. I'm going to highlight this triangle. Okay, I'm going to draw it separately down here. This is 8 and this is 17. And that's down here is x. Okay. So all the way across here is 17. And I have that missing piece. I'm trying to find x. So I'm going to use Pythagorean theorem. If you are a little rusty on Pythagorean theorem, you know, you can always look up Pythagorean theorem online. And of course, I'll explain it to you right now. But you're going to be doing a lot of Pythagorean theorem in this chapter and in the future. So Pythagorean theorem is a squared plus b squared equals c squared. The a and the b are the legs, and the c is the hypotenuse. The c is across from the right angle. You can use a calculator on these. Okay, thanks. So, make sure that the one across in the right angle is the C. The A and the B are the legs. So if you put them in the wrong spot, it doesn't make a difference. I'm going to actually write x squared here. So, oops, C is 17. So, x, I don't know. I know the 8, I know the 17. I plug those in, and I just have to solve for x. You know, some people do this on the calculator. They don't even write anything down because they say, okay, you know, I would end up doing 17 squared minus 8 squared. If you're at all unsure about this, I would write it out. Use a calculator if you need to. I get 225. I got x squared equals 225. I do the square root and I get 15. And that's the answer to that one, is 15. Yes? That's a good question. So, I won't give you ones that are irrational most of the time. So it won't be like square root of 15, which is some decimal. But it could be like 2.5 or something that is not necessary to round. So if you get something that you have to round, I would be suspicious that something's wrong. And when you get whole numbers like this, these actually have a name. They're called Pythagorean triples. And so some people just memorize these. Like this one is a Pythagorean triple, 8, 15, 17. So if I give you a triangle with legs of 8 and 15, and you memorize, you say, well, I don't have to do that. I know 8, 15, and 17 go together. So I'll write the name of this. It's called a Pythagorean triple. And I'll occasionally tell you the Pythagorean triples. I don't make people memorize them. But if you do memorize them, you will save yourself some time. And I'll kind of tell you Pythagorean triples as we go. So 8, 15, 17. In other words, you know, if you had 15 and 17 and you were looking for a leg, it's going to be 8. And so only certain numbers come out to be whole numbers, and we do those a lot. So that's a good question. And I will tell you Pythagorean triples as they appear in the notes. We'll probably see a lot of them. Okay, let's do another one and see how it goes. So this one says BC is 9. AC, which is all the way across here, is 2x minus 5. So AC, I'll highlight, is all the way across here. But then it says DE, and DE is not all the way across. DE is just from there to there. And then it says find the perimeter of the triangle. So, I know that if that's 9, that's 9. Okay, that's not super helpful. We just found out that if we know the diagonal, we can find the sides. And we need to come up with some kind of equation here. Do you think I should make these two things equal to each other? DE and AC, should I just set them equal like I did in the last problem? No. Okay. The rule that we learned is these are both split in half. But not only are they split in half, they have the same length. So all 4 of those are equal. All 4 of the things I marked are equal. So somebody want to raise their hand and give me an equation that they think would make sense? Grant, go for it.
2x minus 5 equals 1/2 x plus 5.
So you want to make these equal? So they're not equal in length because this blue one is definitely shorter than this yellow one. So you don't make them equal. You're going to use an equal sign to make an equation, but they're not equal to each other. Any other ideas? Let me ask you this question. Okay, let's just hypothetically say that this was a 5. Do you think if you knew DE, you could find AC? Okay, you would double it, correct? Okay. Do you want to try it again? So, and then add this one and this one?
No, add DE to itself.
So add this one to itself? So that's the same as doubling it, right? So I'm gonna write it as doubling. If you added it to itself, that wouldn't be wrong. Okay? So and Grandma's probably not the only person thinking like that. If you did DE plus EB, which is the same, 1/4 x plus 5 plus another 1/4 x plus 5, that would work. Okay? A lot of people do it that way. I like to write it this way. I would say doubling DE should be AC. Does that make sense? Are we happy with this? Okay. Now we have to distribute the 2. 1/4 of 2 is still a fraction. It's a half. I end up with some fractions here. It's not going to be too big of a deal. I have to subtract the half x from both sides. I'll just use a decimal here. 2 minus a half is 1.5. Okay, I'm going to zoom in on this so you can see it better. Then I'm going to subtract 5, and I get 5 equals 1.5x. Divide and you get divide by 1.5. Let me quit out of here. So I have 5 divided by 1.5, and I get 3.3 repeating. 3 1/3. All right, if that's what it is, that's what it is. So I did that right? I'm surprised that's what I would have for that. All right, well, it seems unusual that I have that. I didn't make a mistake, did I?
Wait, it's minus 5 for the equation for AC.
Oh, I wrote AC wrong. Okay. I wrote the thing wrong. All right. I knew something seemed odd. Okay, because it was going to come out to be numbers that are less. I just wrote the thing wrong. This was a minus 5. If I make a mistake at the beginning of the problem, tell me. So we had the right idea. I just wrote the problem wrong. I solved the wrong problem correctly. But I want to solve the right problem correctly. So this gives me 10. Okay, that sounds more like what I would want. If you would have checked that answer, they would not have came out to make sense. DE, I'll do in a second. Let's do AC first. So AC would be 20 minus 5, which is 15. DE is 1/4 of 10. 1/4 times 10 plus 5. I got 7.5. Does that make sense? 15 and 7.5?
Yeah.
Yeah, because all these pieces are 7.5, 7.5, 7.5, 7.5, 7.5, because 7.5 plus 7.5 is 15. Okay. It asks for the perimeter of the rectangle. Now, I don't have AB or DC. There's another Pythagorean theorem. So I'm going to take this and separate out a triangle that's a right triangle. And this is 9, and this is 15. And I have to do the Pythagorean theorem again to find that missing side. This is going to come out to be a whole number. 9 squared plus that missing side squared equals 15 squared. This is 81 plus x squared equals 225. I know I'm going a little bit fast here, but you said the Pythagorean theorem. The x is a leg, so you can make it the x a or b. The 15 has to be the c. And I'm just solving this now, and I get x equals 12. This one is not considered a triple because it is a certain triple multiplied by 3. It's a multiple of 1. So when we talk about the triples, I'll explain that more in the future. But you just do the Pythagorean theorem, you get 12. So these are both 12. And then once you know that they're both 12, then you can do the perimeter of the rectangle. If you don't know what perimeter is, it's adding up all the sides. And so you'd have to add these 4 numbers. You should at this stage know what perimeter is. This is probably not the first time you've heard perimeter. Perimeter is adding up all the sides. It's totally different than area, which is the space inside the figure. If you get those words confused, you have to unconfuse yourself really fast because the second half of this chapter is an area. Perimeter is adding these. I just multiplied them because I was talking about area. Oops. You add them. Don't multiply. Multiplying them will give you the area. Oh my gosh. Keep hitting the wrong button. You can probably add these in your head. You get 42. And there's no units on this. So you just say perimeter is 42. If you want to label it, you label it units. 42 units. You know, these are an unknown unit. We don't know if they're inches or centimeters or millimeters or whatever. Then I wrote some true and false here. Why don't you take a second to read all these true and false? And, you know, we don't have too much time for you to spend on these. Just write true or false really quick, depending on what you think. And then we're moving on to rhombuses. Now we're going to go one step further on these. And so we're going to write true and false. And on the true ones, I want you to say whether you think it's a special rectangle property or it's just a parallelogram property, if that makes any sense. So what do you think about A, true or false? Yell it out. Don't be shy. It's true. The diagonals by each other. Is that a special rectangle property or is that a parallelogram property? In a parallelogram, the thing we learned about the diagonals is they bisect each other. That's a parallelogram property. Everything that's true about a parallelogram is true about a rectangle. So that's true. The symbol for parallelogram is parallelogram. It's not a little parallelogram. It's a parallelogram property. The diagonals of a rectangle are congruent. True or false? True. Do you think that's a parallelogram property or a rectangle property? That's a special rectangle property, which I'll just draw a little rectangle. The diagonals of a rectangle are always perpendicular. That means they hit at a right angle. True or false? That's false. That's not true about rectangles or parallelograms. It might be true, but it's definitely not always true. The opposite sides of a rectangle are parallel and congruent. True or false? True. Is that a parallelogram property or a rectangle property? That's a parallelogram property. If it's true about a parallelogram, it's automatically true about a rectangle. The four sides of a rectangle are congruent. All four sides being equal. True or false? False. Okay, they might be all equal, but that's not always true. The four angles are always congruent. True. Is that a parallelogram property or a rectangle property? That's a rectangle has four right angles. A parallelogram doesn't. That's a rectangle property. So these two were special rectangle rules. The rest were either false or parallelogram rules. All right, we're moving on to rhombuses. So there's not a right way to say this. You could say rhombuses or you could say rhombi. It doesn't make a difference, okay? So I know this one says notes too, but obviously we didn't finish the other one the other day. Actually, I'm gonna stop this video and make another video on rhombuses.